We finally got onto task. All right, so we're doing more factoring again. Here's some crazy factoring problems today out of the book. So what I like to illustrate is what we do when we multiply, and then we're going to be factoring. So this is me showing you that if you multiply these together, what happened? A lot of things canceled out, right? What'd you get? What was your final answer? Plus 27. Very good. X cubed plus 27. This is called sum of cubes. Sum of cubes. Why? Because it's a sum of perfect cubes, meaning we have x that's being cubed and we have 3 that's being cubed. And so I know mathematicians are so, literal when they give you like titles, okay? It is literally called sum of cubes because it is a sum of perfect cubes, okay? So the nice thing is that if I asked you to factor sum of cubes, it's a pattern every single time. And so we're going to start with sum of cubes over here, and you're going to back up into the bubble form, factored form. And I'll tell you what that pattern is, but I bet you can kind of see the start. How does x plus 3 relate to the cubes? It's the root. It's the cube root of those things, okay? And so then there's a pattern to get this second bubble. If you have sum of cubes, it's always going to factor into a small bubble and then a big bubble. And that's pretty much how I discuss sum of cubes. Small bubble, big bubble. Why? Because it's a little bubble and then a bigger bubble. Okay. All right. Down here, a bunch of stuff canceled out again, right? What did you get left with? X cubed minus y cubed. What's this called? Difference of cubes. C-U-B-E-S. Difference of cubes. Again, because it's subtraction of perfect cubes. Okay? This is essentially the pattern. You'll notice it's x being cubed minus y being cubed. And the first bubble is just made up of those bases there. Okay? What I'd like to point out is the sign matches. The second sign changes. The third sign is always positive. Keep the sign, change the sign, always positive. Keep the sign, change the sign, always positive. All right, we're going to talk more about these patterns. That's what we're starting with today. All right, so here we go. Example 1, factor the expression. So again, factor means put it into bubbles. Factor the expression. Factor the expression. We have x cubed plus 8. This has a special name. What's it called? Sum of cubes. It's sum of cubes because it's x being cubed plus what? 2 being cubed. Okay? Sum of cubes because it's x being cubed plus 2 being cubed. Now, if I want to factor this, it's always going to factor into small bubble, big bubble. Always, always. Small bubble, big bubble. And I do the signs first. The signs go, keep the sign, change the sign, always positive. Keep the sign, change the sign, always positive. Okay. Now, what goes in my first bubble? X and 2. Whatever the base is there, X and 2. Once you get that first binomial, then you get the rest of the binomial by a really easy pattern. And that pattern is square the first thing. X being squared is X squared. Okay. Multiply in the middle, meaning we're just going to multiply our 2 and our X together. 2X. And square the last thing. That's why it's always positive, because you're going to square it. And 2 squared is 4. Square the first, multiply in the middle, square the last. That's it. That's factor. And that's just one of the patterns that you have to memorize, unfortunately. There's no way around it. I don't like having you have to memorize things. It should just make sense. No.
Why is 2x negative?
The pattern. Yeah, that's how it's going to cancel itself out. So when you distribute, your x times negative 2x, that'd be a negative 2x squared. 2 times x squared, that's the positive 2x squared. So that's how it cancels itself out. Okay?
So it also multiplies into that?
So again, if you want to prove to yourself that it works, then we could multiply it just like we did in the do now. It's just a weird pattern. We're going to try another one. We have 8x cubed minus 27y cubed. What's this called? Difference of cubes. Getting the hang of this now, yeah? Okay. So what is being cubed to get 8x cubed?
2x.
2x is being cubed. 2x times 2x times 2x is 8x cubed. Then we have a subtraction sign. And now what is being cubed to get me 27y cubed? 3y times 3y times 3y. Okay. No, you don't have to include the sign. Yeah. Yeah, the sign, that's why the pattern I think is challenging, because you actually do the signs independently. So small bubble, big bubble. What do you think the signs, how do you think the signs go? Keep the sign, change the sign, always positive. Keep the sign, change the sign, always positive. All right? Keep the sign, change the sign, always positive. Now, what goes in the binomial there? 2x minus 3y. There you go. The 2x and the 3y get plugged in. And now to fill the big bubble, we do square the first, multiply in the middle, square the last. So I'm going to square the first thing. What is 2x? 4x squared. Good. So squaring the whole thing. 2x times 2x is 4x squared. We multiply them together in the middle, ignoring the sign. We've already taken care of it. Thank you so much. Awesome. Thank you. So what goes in the middle? 6xy. 6xy. And then square the last. 9y squared. And that's it. Okay. And again, how do you know if you did it right? You could distribute and combine like terms, and everything will cancel out and get you back to what you started with. Okay? But God, I don't want you to do that. I just want you to learn the pattern. Yes, sir.
A quick question. So
Yeah.
you said middle part is 2x times
3y.
3y.
Ignoring the negative. Yes. Don't. So that's why we do the signs independently, meaning you don't have to think about them now. Yeah. Good question. All right. Last one. What's this called? I think that's supposed to be a 125. Let's do that. Yeah, 126 is not right. Typo. No, it should be 125. A total typo there. Sorry about that. You guys, normally I teach two, but there's only one section, you guys, so I don't have a guinea pig to test it out on. So you guys are the guinea pigs. All right. So tricky, tricky, tricky. Again, this is sum of cubes. So what being cubed gives you 8x to the 6th? 2a squared. Very good. 2a squared times 2a squared times 2a squared would give you 2a to the 6th. I'm sorry, 8a to the 6th. Plus, what gives you 125b cubed? 5b. 5b times 5b times 5b is 125b cubed. All right, so we've got a small bubble and a big bubble. What are the signs? Plus, minus, plus. Or minus, plus, plus. All right. What goes in my binomial? 2a squared and 5b. Then we're going to square the first thing. What do you get when you square that? To the 4th. 4a to the 4th. 2a times 2a squared times 2a squared. And then we multiply. God bless you. Multiply in the middle. What do we get in the middle? 10a squared b. Very good. And we square the last thing. 25b squared. All right. Raise your hand if you think you've got the pattern down. Good, 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 good. Okay. Square the first, multiply the middle, square the last. Okay. That's not it. For each of these, I hope you can do these independently. These are factor completely. We have learned a whole lot of ways to factor over the past few days. We can double bubble. First times first, last times last, check the rainbow. Check the rainbow. That usually works if you have 2 or 3 terms. The most important one is GCF. GCF first. Always, always, always check to see if you have a greatest common factor. All right, greatest common factor. Can you double bubble? Or factor by grouping. We did factor by grouping yesterday. Or just now, do you have sum or difference of cubes? Because that's a different factor pattern, okay? And so this is us combining all of those things to try to figure out how to get this polynomial down into bubble form, where everything is just being multiplied together, okay? So what do you notice on letter A here? Take out a 2. Take out a 2. What's left behind? X squared minus 4. Very good. And then, what can we do with x squared minus 4? It double bubbles. Whoa. This is difference of squares. Difference of squares. But it factors the double bubble way. Same thing. What times what is x squared? X times x. And then last times last has to be negative 4. What times what is negative 4? Positive 2 or negative 2. What's going to happen when you check the rainbow? It tastes like Skittles right now. The rainbow, it cancels out negative 2x and positive 2x. That's why we don't see that middle term. The middle term is missing. That's factor. All right, letter B, 3x cubed minus 3y cubed. What do you notice? Lots of 3's, right? There's a greatest common factor, GCF. Let's take out the 3. What's left behind? X cubed minus y cubed. What's that? It's difference of cubes. We just learned that. How does that factor? Small bubble, big bubble. What do the signs do? Keep the sign, change the sign, always positive. All right? And what goes in the binomial then? X and a Y. Mhm. And then how do you get the rest of that trinomial? Square the first. What's in the middle? XY. Multiply in the middle and y squared, square the last. You will never be able to double bubble that trinomial. Ever. You cannot, it doesn't go any further. Okay? So that's kind of nice to know. When you use that pattern, it's done. So there is fully factored. So factor completely is really kind of rough, and you have to keep asking yourself, can I do more? Can I do more? Can I do more? You guys had an extra credit last weekend. That was just like all of these. This is a trinomial. A trinomial. Try to factor. Try to double bubble. All right. Same pattern as I initially taught you that first day. What times what is x to the fourth? X squared times x squared. And then last times last has to be negative 27. What times what is negative 27? Negative 9 and positive 3. You guys are really good. Negative 9 and positive 3. Okay. Are we done? Good. This first one goes further. What's it called? Difference of squares. Very good. So it goes further. Double bubble that guy. How does he double bubble? X plus 3, x minus 3. First times first is x squared. Last times last is negative 9. Positive 3 times negative 3 is negative 9. This one doesn't go any further because it's not a square. Although technically it is a square. But I'm not going to ask you to go further right now. That is fully factored-ish. What about letter D? What do you notice on letter D? They all have a Y. There's a GCF. And a 3. How do you know 84 is divisible by 3? Very good, yeah. You can add up the digits. 8 plus 4 is 12, and 12 is divisible by 3, which means the number is divisible by 3. Yeah. All right, so let's take out a 3y. What's left behind if I take out a 3y? X to the fourth plus 3x squared minus 3 goes into 8 2 times with 2 left over. 3 goes into 24 8 times. There you go. All right. Are we done?
Yeah.
No. This is a trinomial. What do you need to do? Try to factor it. Yeah. See how it works there? All right. First times first has to be x to the fourth. What times what is x to the fourth? X squared times x squared. And then last times last has to be negative 28. What times what is negative 28? 7 times negative 4. Very good. Positive 7 and negative 4. All right, good. Are we done? No, why not? Difference of squares. I love how you're using the language. Good language. Okay. So yeah, I know. Isn't this great? You just keep on going, right? All right. How does x squared minus 4 factor? Very good. Very, very good, ladies and gentlemen. That is fully factored. All right. So we're not done because I got more. So this, if these were all X's and not a Y, when I look at this, I have a picture in my head because this is a graph. It's a graph, ignoring the Y. So we're going to learn how these factors connect to the picture of a graph. And it's very cool. No. Not like this. You couldn't take it out here. You'd have to do it before we were all in bubble form. You can't do it here. Because it's only one term. It's not like we have 3 separate terms. Everything is connected by multiplication. So you can't take any, it doesn't work that way. So it has to be separated by addition or subtraction. Weird. Good question. All right. Okay. I feel like there's a page missing here. All right. Oh, well. Okay, this is the last 2 things here. Factor with patterns. I feel like something is missing though, so I don't. Oh well. So on this first one, what's this called? Difference of squares. Difference of squares. So it factors pretty easily. How does it factor? Guys, in group 1, x times x is x squared. And then negative y and positive y. Very good. So difference of squares is super easy. All right. You know how to do that. Is this different than that? No, it's not. So part of what you guys have to do a lot faster, just because you're in this class, this is what we do in pre-calc. This is what we do in algebra 2. Okay? You guys have to learn, starting here and be able to get here all now instead of having a whole year to figure this out. Okay? So you have to be able to step back and look at the overall structure. When I look at this, I see I have something being squared minus another thing being squared. All right? And so it fits the same pattern, meaning what times what is x plus 4 quantity squared? X plus 4 times x plus 4. All right? It's being squared. It fits the pattern. Okay? And then, just like before, last times last has to equal that negative y squared. Well, that's positive y and negative y. So now my question is, are those parentheses doing anything right now? No, there's nothing to distribute, nothing really. So really, we can sort of just reorganize this as x plus y plus 4 times x minus y plus 4. It's weird, but what we need to look is be able to step back and look at the overall structure. This is still difference of squares. So first times first has to be this thing squared. It is. Okay. And then some weird things happen after that. But so looking for patterns within patterns. Okay. Ladies and gentlemen, very good. You're excellent factorers. If you guys can get started on class practice 15, please write the original problem. Write the original problem and be a